Hello students, welcome to my channel CGAT Maths. Myself Dr. Suresh Brother. In this video, we are going to discuss an example based on irrotational vector. Show that the given vector is irrotational and also find the scalar function phi such that del phi is equal to vector. So by considering this equation, we have to find out phi value. Okay, first let us show that the vector f is irrotational. Definition of irrotational we know already. Irrotational means irrotational or some vector f is said to be irrotational, then the curl of that vector should be equal to 0 vector. Curl of that vector is equal to 0 vector, we say that it is irrotational. So curl f means we know already del cross product of del and vector f should be equal to 0 vector. Okay, fine. Let us prove this one first. Okay. What is del cross vector f? Is a second order determinant. The first row contains I, j, k. The second row contains component of del. What is actually del? Del means dou by dou x I plus dou by dou y into j plus dou by dou z into k. We are writing the coefficient of ijk, that is dou by dou x, dou by dou y, dou by dou z. In the third row we are writing the coefficient of ijk of a vector f, which is y plus z, x plus z or z plus x, x plus y. So let us expand this determinant along first row. You can expand along any row or any column. So I am going to expand along first row. Okay. Leave the first row, first column, I into dou by dou y of x plus y. Dou by dou y of x plus y minus dou by dou z of z plus x. You know the coefficient, you know the signs of a third order determinant, plus minus plus a minus j times of. Leave the first row, second column, dou by dou x into x plus y. Dou by dou x into plus y minus dou by dou z into y plus z. Dou by dou z into y plus k times of. Leave the first row, third column, dou by dou x into x plus y. Leave the first row, third column, dou by dou x into z plus x. Z plus x minus dou by dou y into y plus z. Can check it once again. Leave the first row, first column, dou by dou y plus y, dou by dou z, z plus x minus j into, leave the first row, second column, dou by dou x into x plus y minus dou by dou z into y plus z plus k times of, leave first row, third column, dou by dou x into z plus x minus dou by dou y into y plus z. Okay, fine. Now let us differentiate partially here. I times of differentiation of dou by dou y, sorry, differentiation of x plus y with respect to y. X is 0, y is 1, minus differentiation of z plus x with respect to z is 1, x is 0, minus j times of differentiation of x plus y with respect to x is 1, y is 0, minus differentiation of y plus z with respect to z. So y is 0, z is 1. So we are keep it remember that keep in remember that we are differentiating partially, plus k times of differentiation, partial differentiation of z plus x with respect to x is z is 0, x is 1, minus differentiation of y plus z with respect to y is 1 plus 0. Look at 0 plus 1 is 1, minus 1 plus 0 is 1, 1 minus 1 is 0. This is 0 into I, again 1 minus 1 is 0, plus 0 into j, here also 1 minus 1 is 0 into k. So this is 0 I plus 0 j plus 0 k is same as 0 vector. So what is your conclusion? Conclusion is you have got del cross f equal to 0 vector, or curl f is equal to 0 vector. It shows that f is vector f is irrotational. Okay, fine. So what is the next step? We need to find out a scalar function phi such that del phi is equal to vector f. Look at, you need to take del phi equal to vector f. You know del phi value. Del phi value is dou phi by dou x I plus dou phi by dou y into j plus dou phi by dou z into k is equal to vector f. You know already. Vector f is y plus z into I plus z plus x into j, z plus x into j plus x plus y into k. Okay. Students, left side you have a vector, right side also you have vector. Then the corresponding coefficients of I, j, k are equal. That is dou phi by dou x is equal to, equate first coefficient of phi, you will get y plus z. Similarly, equate the coefficient of j, dou phi by dou y is equal to z plus x. Similarly, dou phi by dou z, that is coefficient of k, you will get x plus y. And look at carefully. So this is these are called simultaneous partial differential equation. Simultaneous partial differential equations. So how to solve these one? These are solving by the help of direct integration. Direct integration. Students, we are already aware of direct integration method in the what partial differential equations. Okay, it is very easy one. Okay, so let us differentiate partially. Look at, you have dou phi by dou x. Look at the denominator. So denominator containing a independent variable x. So what you need to do is you need to integrate this first equation with respect to, integrate first one with respect to x, second one integrate with respect to y, third one integrate with respect to z. So what will happen on integration? Integration of dou phi by dou x is equal to integration of phi plus z to x. Integration of dou phi by dou y, integration of z plus x into dx. Similarly, integration of dou phi by dou z is equal to integration of x plus y to dz. So now look at this very carefully. So we need to integrate first term with respect to x. Okay, try to understand. It is very easy one. Okay, and also here we are using one of the important result: integration of differentiation of any function f of x is same as f of x. Okay. Here also integration of differentiation of phi is just phi is equal to, look at here right side we are integrating with respect to x. Okay. Here you have y. Okay. So first I am writing this is integration of y into dx plus integration of z into dx. Then it is more useful. Further here you will get phi again. But one thing we should remember here, what do we need to remember? Here we have integrated, so we need to add the arbitrary constant. It's very important. But we are not integrating ordinarily. Okay? Because here we have more than one independent variable. For that, students, here what are the independent variables? X, Y, Z. So phi is only the dependent variable. These are independent variables. Here phi is dependent. So whenever you integrate with respect to x, add the arbitrary constant c as a function of remaining one, y and z. So here what we need to write here, we need to add here it as f of y comma z. This is very important, you should remember. Okay, fine. Further, you can write it as f1. Okay. Next. Here you will get again phi is equal to, I am writing separately. This is z dy. Sorry, z dy plus x dy. So what is the arbitrary function here? I am writing as a f2 of, here we have integrating with respect to y. So for that we need to add the arbitrary constant as arbitrary function of x and z. Similarly, in the third one, phi is equal to here this is integration of x dz plus integration of y dz plus arbitrary constant as a arbitrary function of f3 of x and y. Okay, so further phi is equal to, so integration of y dx, y is a constant, you can write y outside. Integration of 1 dx is just x. Here z is a constant, you can take z outside. Integration of 1 dx is just x plus f1 of y and z. Similarly, phi is equal to, z is a constant, take outside. 1 dy, integration of 1 dy is just y. Here also x into integration of 1 dy is just y plus this is f2 of x and z. Similarly, phi is equal to, x is constant with respect to z. So 1 dz is just dz. Sorry, 1 dz is integration of 1 dz is just z plus integration of y dz. Y is a constant, 1 dz is just z, plus this is f3 of x comma y. Students, we have three values of phi. We need to write a unique value of phi here by observing all three. Okay. So we also give the values to what f1 of y comma z, f2 of x and z, and f3 of x and y. Okay. So now I will write here itself. Just you can concentrate carefully. So I need to write phi value, and also here I am going to write f1. F1 of what? YZ. Similarly, f2 of x and z. Finally, f3 of x and y. I need to give the values to these. Fine. Look at the first phi, it containing xy. In the second value also containing xy, but third value of phi does not containing xy, but it containing f3, f3 of xy. So you can take f3 of xy as just xy, then xy is present in all three and write xy here. Similarly, you can observe zx present in first equation, zx or xz present in the third equation, but zx or xz is not present in the middle one. So you need to take f2 of xz. Xz is our function of x and z. You can take it as xz. And xz is present in three equations. You write here xz or zx. Finally, okay. Yz is present in the second one, third one, and it is not present in the first one, but first one containing f1 of yz. You can take f1 of yz as just yz. Therefore yz is present in all three. Therefore this is the value of phi. Thank you so much for watching. We'll meet in the next video.